A quick review, yesterday we talked about heating curves as well as cooling curves. In a heating curve or a cooling curve, we are talking about a phase change, which means we are going between different phases or different states. For a heating curve, you start off as a solid, then you melt and become a liquid, then you vaporize and become a gas. You'll notice that I have these states labeled, solid, liquid, and gas. And I also have the freezing point and the boiling point labeled. Our axes are going to have time as our x-axis and temperature as our y-axis of a heating or cooling curve. Today we are talking about a phase diagram. Phase diagrams are different. We're going to have different axes. On the bottom now we're going to have temperature, and on our y-axis, we are going to have pressure. Yours is going to look a little different than mine, but it's going to follow the same overall appearance. Typically, you have one line going across and another one here. You'll notice that this makes 1, 2, 3 regions. Instead of labeling lines like our heating and cooling curve, we're now going to be labeling our regions, which means at our lowest temperature and at high pressures we have solids. At high temperatures and low pressures we have gases, and in between we're going to have liquids. There are a couple of points we're going to label. We're going to have TP, CP. Going through this, I'm going to first talk about what it means if we are going across a line. So if I go from a solid to a liquid, that is a phase change, and I'm going to be going from solid to liquid, so this is melting. The opposite of this would be freezing. Going from a liquid to a gas would be boiling, and from a gas to a liquid would be condensation. Solid to gas is sublimation, and gas to a solid is deposition. So we know that a phase change occurs when crossing a line. So the key to this is we're crossing a line. We're going from one phase to a different phase. Now, if I am on a line, such as this line between a solid and a liquid, if you are on a line, both states exist in equilibrium. So on a line, we exist in equilibrium, meaning I can see both states, and I'm going to see it half the time as a liquid and the other half the time as a solid. You'll notice that there's a point where all three states are touching. That's my triple point. So TP, which is our triple point, at the triple point, all three states of matter exist in equilibrium. You'll notice at a certain point between my solid and gas and liquid line, I'm going to follow this line that's touching gas and come to a critical point. At the critical point, it's the point, so critical point is the point when the substance acts as both a liquid and gas. So anything past this point in this area is going to be a supercritical fluid. So a review, our axes are temperature on the x-axis, pressure on the y-axis. Going across a line is a phase change. Each region of the graph is a different state of matter. When we are on a line, both states that the line touches exist in equilibrium, so we'll see just as much liquid as we do gas. Where all three states touch is a triple point, where all three states exist in equilibrium. And at the end of the line between liquids and gas, we have our critical point, and anywhere beyond this, we're going to behave like both a liquid and a gas. We can cause a phase change by either changing pressure, and if I change pressure, I'm going up or down, or by changing temperature, well, I'll go across. So let's add that as well. Change of pressure goes up or down the diagram. Change of temperature goes left or right on the diagram. So what this means is I can cause a phase change. So I can cause a phase change by changing the pressure. So I can go up or down. So I could go from a gas to a solid or liquid to gas by changing my pressure. Or I can cause a phase change by changing the temperature. I could increase my temperature, so increase the heat source, and go from a solid to a liquid, or liquid to gas. The other points you're going to need to know will be the normal boiling point and the normal freezing point. So, looking at my graph, pressure is going to be in ATM. This stands for atmospheric pressure. And we're going to have an atmospheric pressure of 1 ATM as our normal. So we'll draw a line across. This will be our normal point where I go from a solid to liquid. So solid to liquid means we're going to have our normal freezing point. And then our normal boiling point is when we're going between a liquid and gas, but we're at 1 ATM. So this would be my normal boiling point. So normal boiling point and freezing point occurred at 1 ATM. And that should be your entire labeled phase diagram.